Apply pre-cal. It's good to see you. Oh, you know what I mean. I hope you had a fantastic spring break. And yeah, we're back. We're going to jump right back into it. As you can see, I'm in a different place right now. If I look a little bit funny, it's because I don't have my glasses on, because I have a light right here and it reflects. It's kind of weird. But yeah, we're setting up a new space. That's what this is going to be. It's not quite ready yet, so it'll be difficult to do board lessons immediately. As it turns out, though, where we are in our unit is dealing with interpreting and sketching graphs. And it's really useful to demonstrate that with a graph. Kind of makes sense, right? So I'm going to be switching over to my document camera or my screen capture software, the Bandicam, and I'll be showing you on my computer how to work through interpreting and sketching graphs. So I'll see you over on that side, and we'll take it from there.
Okay, applied precal. So we're now on the document camera, and we're going to be looking at interpreting and sketching graphs. So let's jump right into it here. I'm going to give you a graph of a scuba diver diving, and let's draw it first, and then we'll talk about what's going on here. So we just let it draw. That's what it looks like. From this image, the goal is that you will be able to see an image and explain what could be happening. Not necessarily what is happening, but you can give us an idea what could be happening. So let's work on this line diagram to start with. On the x-axis, that's on the bottom of the graph, we've got our time, which is registered in minutes. And on the y-axis, that is our up and down side, or the vertical axis, that's on the left side here, and that's explaining the depth of the scuba diver in meters. So it seems kind of counterintuitive, but the higher the graph goes is actually telling us how much further the scuba diver has dived or dove. It's a good thing I don't teach English. It's telling us how far the scuba diver is submerged beneath the surface of water. So it's a little bit tough to wrap our heads around that initially, but that's what this graph could be explaining here. Let's first highlight a section here. So that's this green section. You don't want to pause the video, but think about it. What do you think is happening in this case? It takes about 4 minutes, and the depth increases from 0 to 12 meters. What does that mean about the scuba diver? And essentially, they're just telling us that it took 4 minutes for this scuba diver to dive 12 meters below the surface of the water. Now, immediately following that, we have this yellow section, and the yellow section is flat, which is kind of strange because time continues, right? From 4 to 8 minutes, the scuba diver was just hanging out for about 4 minutes, and we know that because their depth hasn't changed. We don't know what they're doing. Maybe they're waiting for a buddy, maybe they found something, they're taking pictures. We have no idea. All we know is that they are not diving at this point in time. Immediately following that, though, for the next 4-ish minutes, it looks like, oh, it's actually less than 4 minutes, it looks like the diver is continuing their dive, and they go an additional, 8 meters, so they end up going 20 meters deep in total. And the slope of that line, so the direction that line is facing or moving in, is actually the same as our initial dive. So the clue that we can interpret in this situation is that anytime our slope is moving from the bottom left corner in the top right direction, our diver will be diving. And we should be able to include the opposite as well. If our graph is moving from the top left to the bottom right, it could mean that our diver is surfacing. Before we get there, though, we have another section of flat, which means that our diver has stopped diving again, and it's the exact same graph or same shape as we had before on our other flat line. So at 20 meters below the surface of water, our diver is just hanging out. Don't know what they're doing, but they stopped diving. The conclusion of our graph is this purple section here. That's going in the top left direction to the bottom right direction. So we've concluded previously that our diver must be surfacing in this situation. Okay, so there's a lot of information there. We can make a lot of assumptions on what our graph is telling us. We can't fully conclude on anything, but we can at least make sense of what's going on. Now, I'm going to show you the graph one more time just so that you can see what it looks like without all the highlights on it. If you want to take any notes on the graph, this would be a pretty good time to get that in. because we are moving on to the other type of graph that you can see, which is often a dot diagram or symbol diagram. If you prefer the dots, you can draw the dots in there. I honestly don't care. I personally prefer the symbols or letters, so that's what I use, but you can use dots if you prefer. And we're looking at the mass of chips and the cost of those chips based on how much they weigh, or how massive they are. And to solve this type of graph, we're actually going to look at a couple of questions. So I want you to tell me all of these questions over here. Or I don't want you to tell me the questions, I want you to answer the questions for me. You might want to pause, but can you tell me which bag is the most expensive and how much it costs? Which bag has the least mass and what that mass is? Which of the bags have the same mass and what that mass is? And which bags cost the same and what that cost is? Finally, I want to know, out of C and D, which one do you think is a better value for money? So let me pause for a second here. Try to answer those questions. All you get to use is the graph that I've given you here, and then we will look at the solutions. So let's just burn through the solutions here. First question was looking for the most expensive bag, and that has to be C, because our cost is on the up and down direction, the left or vertical axis, the y-axis. So the higher up we are, the more expensive our bag is going to be, and C is the highest of all the bags. So C has to be the most expensive. It's about $7. Bag B would have the least mass, so I'm looking at the second question now. Similarly to C, however, we're looking at the bottom of the graph now. So anything that's closest to the left will be our least massive bag, and in this case it ends up being B. For the third question, D and E have the same mass, and that's because their location is identical on the x-axis. So at about 1800 grams, you're going to see both D and E. Again, similarly, A and E will be about the same cost, but that's because they match up on the same line on the y-axis. That's about $4. Lastly, I'm asking you, which bag has the better value for money between C and D? Well, C is more expensive because it's higher up, and you get less in C because it's closer to the left. So all signs point to D being the more cost-effective option. Now, it doesn't explain to us, what's in bag C and what's in bag D. C might be the best chips you could ever have in your life, and D just might be potato dust. We don't know. But with the information that we've got, we can at least conclude that D is the most cost-effective option. Okay, so this is a quick example on how you can interpret a graph and make sense of it just based on a little bit of information that they give you. I'm hoping that you recognize the value in having these graphs as well, and a little bit later on I'll be asking you to make one for me as well. So until we get there, I'm going to give you some practice. I'll open up a place where you can submit your practice as well, just so that we can do a homework check on it. So I'll post that up on the video. Do your best on that, and if you have any questions, absolutely just send me an email and we'll take it from there. Thanks for watching.